people call it the self-sleep because they add a special feature with the hibernation file, which allows you to encrypt it if you use a special flag. So if you want to extract hibernation file or before hibernating a micro-SX machine, you have to be sure that this flag is disabled. If you want to disable secure virtual memory, you have to use the following command: the pmset hibernate mode 1, because you have like 5 different modes. And if you are using this mode, it should be okay. So the hibernation file is at this path, the private var VM sleep image. So even if you are not using the encryption, the hibernation file is at least compressed for optimization reasons. So anyway, this talk is about the physical memory analysis. It was a short introduction to explain to you how to get a physical memory dump. So now I'm going to explain once you have a memory dump, what you have to do. So the main goal of the method I'm going to introduce is to avoid random string searching, because there is no file system, so it's more or less random. Most of people tend to, forensic experts on most investigators tend to do only string searching until very large file, which is not really smart. So here is the methodology I'm going to explain. So it's like a 4-step methodology. The first step is you first have to get the kernel symbols, because it contains a lot of information we are going to use in the next step, especially to initialize the kernel memory manager, which will allow us to browse the kernel address space. If you want me to summarize these 3 steps, we have a devmain snapshot. So using these 3 steps, we are going to convert the devmem into devkmem. So once we have our own devkmem, we can extract information and collect information. So here is the flowchart, which gives you a pretty interesting overview of what kind of information you can retrieve from a memory dump. So as you can see, you can retrieve very trivial things like syscalls. So at least on Windows, there are not a lot of rootkits using the syscalls, but on macOS it's pretty common. So it's really interesting to see, once you have the syscall table, how you can detect if there is an abnormal behavior. You can also retrieve static information like the machine information, like the kernel-wide version, or at what time it has been compiled, this kind of stuff. You can also retrieve the month file system. So if you want to know if there is a specific device which is plugged on the machine or whatever, you can do that. The kernel extensions, which is the Apple name for drivers or kernel modules. The most interesting thing is probably the processes, because most of user interaction is done with processes. So from processes, of course, you can have access to the thread list. So if you want to browse the stack of this kind of stuff, you can do it. Or if you want to detect if there is a thread injection or this kind of thing, you can do that. One of the most interesting things is you can browse the virtual address space of each process. So For instance, if you are browsing in the address space of Safari, you can retrieve the addresses, where the user was, or this kind of stuff. Or you can also even retrieve passwords. I'm going to talk about it at the end of the lecture. You can have access to file descriptors. It's very interesting because file descriptors is like a generic name for network information, but also for virtual nodes. It's not only about files. So with the file descriptors, you can retrieve information about first the network links, the open directories, and also the open files. And of course, once you have access to the open files, you can check if there is a cache in memory of each file. So the first step. As I said, first we need the kernel symbols. If you are familiar with Windows, you probably know the PDB files. For instance, when you are using Windows Debugger, debugging the kernel, or even with IDA, when you are disassembling Windows DLL or Windows executable, it will download the Windows symbols from the Microsoft server. So it's standalone files. On Mac OS X, it's different. The symbols are inside the executable in a very specific section. The executable to extract the symbol is because in memory, of course, there is the executable